So sometimes you're going to be asked to look at something, the way we have worked problems in the past where something varies directly to something else or varies inversely. Well, another term that you're going to hear is varies linearly. And linearly, it literally means we're going to write a linear equation based on the data that we're given. So 62.3 says the total cost varied linearly with the number produced. When 100 were produced, the cost was $700. When 400 were produced, the cost was $2,200. So we're going to write an equation that gives cost as a function of the number produced. And we know how to do that because we've done this with all of those experiment graphs that we have done in the past where we had to write one element as a function of another. So we know whenever we say that thing is as a function, that's our y term. So cost is our y term. So we're going to say C for our y term, and then M is our slope, and then the number produced is going to be our x term plus B. There's our linear equation that's going to be the format that we use for the data that we're given. So we've got to figure out the equation of this line in regards to the M and the B. But guess what? We don't have a slope and we don't have a plus B. So how are we going to solve this kind of problem right here? We're going to use the data points that we are given. And we are given 2 points. Our first point, our y, is the cost, which is 700. And our number produced is 100. That's our x. And our second point, we have a production of 400 and a cost of 2,200. So we have 2 points. So we can take these 2 points and sub them in and use them as a system of equations in order to solve for both of these variables that we don't have. So let's do that now. We're going to put in 700 for C is equal to M, and our number is 100, that's our x, plus B. Our second point is going to be written as 2,200 is equal to M times 400 plus B. So now we have a system of equations with 2 variables, which we know how to solve. We know how to do this. This is not difficult. It's just getting us there by a different route. And not only that, but now we know that if we are given 2 points, we can solve for the slope and the plus B to find the equation of the line. Easy peasy. So let's do this as a system of equations using elimination to solve it. So let's look at what we need to do. So here we have M to the positive 100, M to the negative 100. Technically, all I really need to do is multiply one of these by a negative 1 so that I can get a negative B. And I think I'm just going to multiply this one by a negative 1. And that's going to give me a negative B value. I'm just going to write it down here so I don't have to rewrite everything. So it's going to be a negative 700 is equal to a negative M400. I'm sorry, looking at the wrong one. So a negative M100 minus B. So this is going to allow me to cancel my B's. And then I'm going to have M300. And then this is going to be, what's 22 minus 7? That's going to be 1,500. So if I divide both sides by 300, then 5 is the value of M. That's my slope. So I can go ahead and say C is equal to 5N plus B. So now all I have to do is go back to my original problem up here. 700 equals, I can put in my slope value, my M value, 5 times 100 which, I mean, I can go ahead and do that in my head. 500 plus b. Subtract 500 for both sides. 200 is my b value. So now I can change the b to a positive 200. So this is the equation that gives cost as a function of the number produced. And that's what we needed to do. So that is whenever you see one of these problems that says something varies linearly, you're going to use a linear equation to solve it. And you're going to turn it into a system of equations using the information you're given to create points. And then you're going to just use the elimination process to solve. And that's all you're going to do. And that is the end of lesson 62. I will see you in lesson 63.